The moon is the largest object in our night sky and also the brightest. A familiar sight to us all. But did you know that the moon's size changes throughout the month? The moon's orbit around the Earth isn't circular, it's slightly elliptical, which means that in the course of a lunar cycle, the moon gets closer to the Earth and then further away. This change in distance means that, seen from the Earth, the moon seems to grow and shrink, and the difference is more than you might imagine. Here's the moon at its furthest distance from the Earth when it's showing its smallest disk. And here it is at its closest. The disk it shows is noticeably larger. The moon increases its apparent diameter by around 13%, and this happens during every lunar cycle. And the apparent area of the moon, the space it takes up in the sky, increases by 28%, so it's almost a third brighter. But it's not just the moon that changes size in this way. The sun also gets larger and smaller thanks to the Earth's elliptical orbit around it. The Earth's distance from the sun changes throughout the year. This 3.5% change in distance means that the sun's apparent diameter changes. Here's the sun seen in July, and here it is in January. The disk seems 3.5% wider, which means the area is 7% larger. So the Earth gets 7% more heat from the sun in January than it does in July. And if this feels the wrong way round, then I'm guessing you're in the northern hemisphere. Those in the southern hemisphere, for whom January is the middle of summer, won't find this strange at all. Let's move to the planets now. We'll start with the biggest planet of all, Jupiter. Although this planet is a giant, 10 times as wide as the Earth, it appears to us as a tiny disk around 1/36th the width of the full moon. This is because of its distance from us, roughly 500 million miles away. This distance changes though. As the Earth and Jupiter orbit the Sun, they're sometimes on opposite sides of the Sun and sometimes on the same side. And so, over a 13-month cycle, Jupiter gets larger and smaller, appearing 64% bigger at its closest approach. For the outer planets beyond Jupiter, this size change is much smaller. These planets orbit so far out from the Sun that their distance from us, and hence their apparent size, doesn't change much throughout the year. So let's move to the inner planets, where the size changes are much more dramatic. First we'll look at Mars. At its closest approach, Mars is around 81 million kilometers from the Earth, and its disk is around 1/100th that of the full moon. At its furthest distance from Earth though, it's 380 million kilometers from the Earth, and its disk is almost 5 times smaller. But Venus, the Earth's closest planetary neighbour, shows the biggest size change of all. At its closest approach, it's only 26 million miles or 43 million kilometers from the Earth. At this distance, it appears large enough to show a crescent and is 1/30th the width of the full moon. When Venus is on the opposite side of its orbit though, this reduces to 200th the size of the full moon. So Venus's apparent size changes by a factor of 6 over a 19-month cycle. But let's return to the Sun and Moon. As we can see, these two bodies change their apparent size as they get closer to us and further from us. The size change is usually not noticeable to the naked eye, but there are occasions when their size makes a huge difference. This is a total solar eclipse, where the Moon passes in front of the Sun and completely obscures its disk. These total eclipses are a familiar sight to most of us, even if we've never witnessed one directly. Not all eclipses are total though. Sometimes the Moon passes over one side of the Sun and produces a partial solar eclipse. These are much more common than total eclipses, and most of us will have experienced them even if we didn't realize it. But from time to time, a third kind of solar eclipse takes place. Some solar eclipses take place when the Moon is at its furthest distance from us and shows the smallest size. If this happens when the Sun is closer to us, the Sun's disk appears larger than that of the Moon. The result is an annular eclipse, where the whole of the moon's disk covers the sun but is just not large enough to produce a total eclipse. The Earth already experiences some annular eclipses, but this will change in the future. Tidal forces between the Moon and Earth are pushing the Moon's orbit higher. As the Moon's distance increases and its apparent size shrinks, there will come a day when there will be no more total eclipses. This won't happen soon, perhaps a billion years in the future, but there will come a day when Earth will experience its last ever total eclipse.